Welcome to Tech Talks. In this video, we are going to break down one of the most misunderstood topics in technology, the difference between artificial intelligence and machine learning. We'll start from the absolute basics: what artificial intelligence really is, what machine learning actually means, and why people often think they are the same thing. By the end of this video, you will be able to clearly explain the difference between AI and ML to anyone, even if they are not from a tech background. So before we begin, if you enjoy content that explains complex technology in a simple and practical way, please do like this video, share it with your friends, and subscribe to the channel.
Most people today use the terms artificial intelligence and machine learning interchangeably, but from an engineering perspective, this is wrong. What most people call AI is actually statistical prediction, not intelligence. Learning patterns from past data is very different from choosing actions toward a goal. When we confuse these ideas, it doesn't just affect definitions, it affects hiring decisions, product roadmaps, safety, and trust. This talk is about separating engineering reality from marketing language. This confusion exists because the meaning of AI has changed over time. In the early years, AI focused on symbolic reasoning and logic. Systems worked using explicit rules written by humans. Later, around the late 2000s, data exploded. Machine learning became powerful, scalable, and profitable. Since the word AI attracted more funding and attention, ML started being called AI. The shift was not scientific, it was commercial. Originally, artificial intelligence was defined by cognitive science, not statistics. An AI system was one that could perceive its environment, reason about it, and take actions to achieve a goal. Symbolic reasoning mattered, planning mattered, search mattered. A system could be intelligent without learning anything new, as long as it reasoned correctly. Machine learning is not intelligence, it is a mathematical process. ML algorithms do not know facts, they approximate a function that maps inputs to outputs. Their goal is to minimize error on data. They learn correlations, not understanding. Generalization is not reasoning, it is statistical approximation. AI can exist without machine learning. Expert systems use explicit rules written by humans. Constraint solvers find solutions that satisfy logical conditions. Automated planners calculate action sequences to reach goals. These systems require zero training data. Every decision is traceable and explainable. That is why they are trusted in high-stakes systems. Machine learning without AI is pure prediction. It can predict fraud risk, it can recommend content, it can estimate probabilities, but it does not want anything, it does not plan actions, it does not understand consequences. Prediction is not agency. Here is how researchers actually think about this. Artificial intelligence is the objective, creating goal-directed agents. Machine learning is a tool used to learn patterns. Deep learning is a technique, a specific implementation. Real systems combine all three. Learning is parameter tuning. Intelligence is goal-directed action. A neural network can memorize without understanding. Humans can reason without learning new data. Accuracy does not equal intelligence. Optimization does not equal reasoning. Machine learning systems depend completely on data. They assume the future will resemble the past. When data shifts, models fail silently. Logic-based AI systems do not depend on data volume. They depend on structure and rules. This is a fundamental difference. Classic AI systems are white boxes. If a decision is made, you can trace exactly why. You can debug logic directly. Modern ML systems are black boxes. Post hoc explanations are approximations, not proofs. That is why ML alone is not trusted in safety-critical systems. ML systems are adaptive but unpredictable. Rule-based systems are predictable but brittle. The best real-world systems combine both. Learning is bounded by logic, adaptation is constrained by safety. Most products marketed as AI are ML pipelines. True intelligent systems require perception, reasoning, memory, feedback, and control. Very few systems meet this standard. Most AI roles today focus on data cleaning, training, and optimization. Reasoning, planning, and symbolic AI are rarely taught. Optimization replaced cognition. That is why AI engineering today is mostly ML engineering. Generative AI models predict the next token. They are fluent, they are impressive, but fluency is not reasoning. Hallucination is a result of probabilistic generation, not failure. They optimize likelihood, not truth. The biggest myth is that scaling creates intelligence. Bigger models improve interpolation. They do not create understanding. Without world models, causality and planning, scale plateaus. Researchers don't ask if a system looks intelligent, they ask, does it fail out of distribution? Does it generalize safely? Does it behave reliably under uncertainty? Benchmarks are tools, not proof. The future is hybrid systems, neurosymbolic AI, world models, causal reasoning, integrated agents. Learning will support reasoning, not replace it. Think of it this way. Machine learning is perception, deep learning is muscle, artificial intelligence is agency. Intelligence emerges when all work together. Stop calling prediction intelligence. Demand clarity over hype. Real progress requires intellectual honesty. Thank you for watching. If this video helped you understand the real difference between artificial intelligence and machine learning, please do like the video, share it with anyone who's confused about AI and ML, and subscribe to Tech Talks for more clear, honest explanations of technology.